Problem 21. A coaxial cable used in the transmission line has an inner radius of 0.1 millimeter and an outer radius of 0.4 millimeter. Calculate the capacitance per meter for the cable. Assume that the space between the conductor is filled with epoxy resin with a dielectric constant 3.6. So here we have to see the diagram. So they mentioned the cable is coaxial cable. That means this cable has two radius. That means a wire inside a wire. So it has two radius, and they clearly mentioned the inner radius takes the value of 0.1 millimeter. That means let's we take from the center of the small, that means the inner wire, this is the inner radius. Let's we take this radius is A. Likewise, exactly from the center to the outer wire, we have the radius, that is outer radius, B value. That means here A takes the value of 0.1 millimeter, and then the outer radius B, which is equal to 0.4 millimeter. Apart from that, between these two wires, that means you can see we have two cylindrical shape, right? That means the wire inside the wire, that means the cable inside the cable. In between these two cables, it was filled with epoxy resin. That means it has the dielectric constant. That means the constant value for the epoxy resin takes the value of 3.6. The K value for the epoxy resin is 3.6. By using the outer radius and the inner radius, by using the value of the dielectric constant of the epoxy resin, what we have to find? We have to find the capacitance per meter for the cable. So before that, we have to write the formula for a cylindrical capacitor. Actually, if you see the coaxial cable, it looks like a cylinder. As we already studied the formula for the cylindrical capacitor, we know the formula for the cylindrical capacitor is C, which is equal to 2 pi epsilon naught L divided by natural log of outer radius divided by inner radius. But here we have to see, they said in between the two cables it was filled with epoxy resin. So that means we have to multiply this equation by K because it's a dielectric. So we have to multiply this entire term with K. Now after that, what we have to find, they ask you to calculate the capacitance per meter. That means we have to again remodify this equation in terms of capacitance per meter. That means we have to take this L to the left hand side of the denominator. By that, your equation will become C over L, which is equal to K multiplied by 2 pi epsilon naught divided by the natural log of B over A. As we already have the value for A and B, the outer radius B takes the value of 0.4 millimeter and the inner radius A takes the value of 0.1 millimeter, and in between the two cables we kept the epoxy resin. That means the dielectric value of the epoxy resin takes the value of 3.6. By using all these, we are going to find the value for capacitance per meter. Clear? So now what we have to do, we have to substitute the value in this equation for get the answer of C over L. So C over L, capacitance per meter of the cable, which is equal to the K value, which is 3.6 multiplied by 2 pi multiplied by epsilon naught value, which is 8.85 multiplied 10 power minus 12 divided by natural log of B over A. So the outer radius they mentioned 0.4 multiply 10 power, because it's millimeter, right? So 0.4. So I have to mention that value here. So 0.4 millimeter. We have to convert that value to meter. So we have to multiply with 10 power minus 3 divided by the inner radius takes the value of 0.1 multiply 10 power minus 3. So now we have to see what's the value for capacitance per meter. So let's see what's the answer. 3.6 multiply 2 pi multiply with 8.85 10 power minus 12 divided by natural log of B value 0.4 10 power minus 3 divided by 0.1 10 power minus 3. So the answer for this question is 1.44. 1.44 multiply 10 power minus 10, but we have to write the unit. The unit for the capacitance is farad and the unit for the length is meter. So the answer for this question is 1.44 multiply 10 power minus 10 farad per meter. That's it. Thank you.